So today we're going to discuss section 8.5, which talks about properties of logarithms. So the three things that we're going to look at are properties of logarithms, how to expand and condense. The book calls it single logarithmic expressions. So expanding it is making it expand into multiple, and condensing it is making it condense into a single logarithm expression. So we start with just some properties, and here they are listed for you. So they are numbered 1, 2, 3, 4, and I will refer to them as property 1, property 2, property 3, property 4. Now, on the right-hand side here, you have the explanation. So this is the property. It says the log base b of 1 is equal to 0. And then it says the explanation is this. So how do they get this explanation? Well, they use what we learned about logarithms. And what we learned about logarithms is, I'm just going to write over here to the side where I have more room, is that I can take and I can say the base raised to the answer is equal to the argument. So I can say that this would be the same as b to the 0 power equals 1. So the reason why the log base b of 1 is equal to 0, because anything raised to the 0 power is 1. The next one, you have the log base b of b is equal to 1. And why this is true is because when you write it in exponential form, it'd be the base raised to the answer is equal to b. So draw the arrows to help you see how to write it in that exponential form. B to the first equals b. And then we have some other problems here, or properties here. So this next one, let me write it out here. It says the log base b of b to the p power is equal to p. So if I rewrite it in exponential form, I'm going to see that this would be the base raised to the answer is equal to this. And so I get this, which is a true statement. And then last here, I have this. This is in exponential form. So this is not in log form, it's in exponential form. So now let's do the reverse. So if I have the base of the log base b of x equals x, I have to do the reverse. So this is my base. That marker doesn't want to work. Here, let's try this one. This is the base. This is b. So if I was to write the log form, I would say the log base b. Now, when we look at our exponential form, this value that you see here is our answer. So I'm going to say the log base b equals, so it would be this exponent. So it would be the log base b of x. And this right here becomes the argument. So this is what I get, and they write it in logarithm form here. And so that is showing why these are true. So those are the properties. Now we don't need to know how to derive them or where they come from, but I'm just trying to show you the background on it. But we need to be able to use the properties. So let's take a look at number 1 here. It says use the properties of logarithms to simplify the expressions. Assume that all variable expressions within logarithms represent positive real numbers, because we know that the argument in a logarithm has to be a positive real number, has to be greater than 0. The argument is this portion here. And so that's why they make that statement. So let's start with this over here. And it says the log base 4 of 4 to the x. So I'm going to take a look as I'm doing these. I'm going to compare them up here. And then I see it says the log base 200 of 1. So the log base 200 of 1, this matches property 1. And I'm just going to write property 1 here. That's this portion. And that could be replaced with 0. It says any base, if your argument's 1, is equal to 0. This part here, the log base 4 of 4 to the x, well, which one does that match? That matches property 3. And property 3 says that if you have the log base be, so the base of the logarithm and the base of this match, then whatever the value up here, that's your answer. So this will be x. So my overall answer would be x plus 0, which would give me x. So pause the video and try it for the next two, and then restart the video and see how I do them. The next one here, this right here, this is property 2. So property 2 says that this would be 1, and this right here, the next part, would be property 3. And so my answer here would be 3. So 1 minus 3, I would get negative 2. The next one, the first part here, this would be property 4. And this would be equal to 7. And this last piece here, this is property 2. The log base 7 of 7, that would be 1. 7 minus 1 is 6. So far we have seen these 4 properties here. And also we're going to look at these properties. These properties are for condensing or expanding logarithms. And they are called, the first one here, number 5, is called the product property of logarithms. If you have the log base b of the argument is 2 items multiplied together, then you can rewrite it, you can expand it to rewrite it like this. So if it's 2 factors, you can rewrite them as x and y separated with a log, separated with a plus sign, and both of them have the log in the same base. Here we have the quotient property. So here you have x divided by y, and you can rewrite it like this with a minus sign in between. Now again, you can go in reverse. So if you were given this, you can condense it into a single logarithm. So if you have a plus sign here, it is the same as multiplying those 2 arguments together. And the last one is the power product property for logarithms. And so this is the log base b of x to the p power. And this p could go down in front and say it's p times log base b of x. So you can bring that p down in front, is what that property says. So now let's take a look at some problems that will use this. And so on the right hand side here, this is the example they give us, and it says to expand this using the sum or difference of logarithms. The sum and difference of logarithms were that property 5 and 6. So we're going to expand this one right here. And I'm going to write here, now they do the expansion for me, but I'm going to write the property that we're using. So they take, this is a quotient, 3x over the square root of y. It's the log base 5. Notice they write log base 5, log base 5. They put a minus sign here. And this is your numerator, this is your denominator. The denominator follows the minus sign. The log base 5 of the denominator follows the minus sign. This is property 6 from up above. Now they take this part, so just this red part here, and they say, well, this is 3 times x. So 3 times x can be expanded further. And you can expand it into log base 5 of 3 plus the log base 5 of x. So these 2 factors can be written with a plus sign in between, but each of them has to have the word log and the base of 5. This is an example of property 5, that multiplication. I think our book calls it product property for logarithms. The next one, now they're taking you're focusing on, in this step, they're focusing on the square root of y. Well, the square root of y can be rewritten as a power. So this is not one of the properties up above, but we can rewrite a square root or any radical as a rational exponent. So I'm going to say fractional exponent because I can take the index here. Now the index is not written when it's a square root. This is a square root, so there's an index of 2, but it's assumed to be 2. It is known to be 2, I should say, not assumed, for a square root. So you take 1 over whatever the index is. So if it was the cubic root, it would be 1 over 3. If it's the 5th root, it would be 1 over 5. So this is rewriting this as a fractional exponent. And then the last step here is now that we have this as an exponent, we can expand it further by using property 7. Property 7 says that you take and you can put that exponent down in front. So this would be the fully expanded. Number 2 says to write the expressions as a sum and difference of logarithms. So this is doing what we did in this example, and we're practicing it in these problems now that follow. And so I'm going to start by looking at this, and this is a quotient. So since this is a quotient, I'm going to say this is the log base 4 of 3x and minus the log base 4 of 64. Now I'm going to take just this portion here, and I can expand this because this is multiplication here. So I could write this as the log base 4 of 3 plus the log base 4 of x. And then I still have this minus the log base 4 of 64. So, and I guess I should write on the side here, this is property 6 we used. That's that quotient property. And this is property 5. That's the product property. Now, is this the furthest I can simplify? This one here, we have numbers here. So when you have numbers in it, you should take a look at it and see if you could rewrite it. 4 to some answer equals 3. I don't really have 4, the base of 4 raised to an answer equals 3. I can't really simplify that. So that one's going to remain. The log base 4 of x, I can't simplify that further. This one here, though, I possibly could. So let's take it over to the side. If I have the log base 4 of 64, let's write it in, and I'm going to just say equals, I'm just going to give it a letter, let's say z. Rewrite it in exponential form. 4 to the z power is equal to 64. So I got to think, what is the exponent that's missing here? I know 4 to the first is 4. I know 4 squared is 16. 4 cubed, well, that's 16 times 4. That's 64. So I can simplify this to 3. So this would be my answer now. So here is my answer. For the next one here, I'm going to use the quotient property first, and I will say this. Then I'm going to use the product property and split this apart because I have x squared and I have x squared times y. So I'll split it apart like this. And now I will use the property 7 and say this is 2 log base 7 of x squared, log base 7 of y, and then here this is z to the 1/2. So I can pull that 1/2 down and say log base 7 of z, and this would be my answer here.